Hi everyone, I'm Mandy. Today I'm excited to share our customer feedback and review management system, which we built as part of our database system. This system tackles some challenges, for example, making sure the data is accurate and reliable, keeping product rating up to date with new reviews, creating an easy-to-use way to organize and manage customer feedback. To make this happen, we use things like database control in check, and we set up triggers to automatically update product rating. We have also designed the system in clean and efficient, reducing redundancy and make it more user-friendly.
Thank you, Mandy. My name is Yong Ting. Now I'll talk about the business rule. For the first business rule is each user can give many reviews, but each review can be given by a user only. For the second business rule is each product can include many reviews, but each review can be included by a product only. For the third business rule is each user can contain 0 or many user action, but each user action can contain by a user only. For the next business rule is each user action can contain a product only, but each product can contain 0 or many user action. Additionally, product and category have a many-to-many relationship. Firstly, each product can invoice many categories, and also each category can invoice many products. For the next business rule is each product can invoice many product categories, but each product category can invoice a product only. For the last business rule is each category can invoice many product categories, but each product category can invoice a category only. Next, I will talk about the ER diagram, which is based on the business rule. In the ER diagram, we can see that the arrow include both dotted line and the solid line. The dotted line will represent the weak relationship between two entities, while the solid line will represent a strong relationship between two entities. And this picture is our ER model for this program. That's all from me. Now I will pass to Jiayun.
Thank you, Ying. So now I will talk about the normalization. There are 3 normalization processes. We start from one entity that's shown here. They have 3 primary keys, which is user ID, product ID, and action ID. In the initial users table, all data is stored in the one entity, which causes data redundancy and dependency issues. So we have first normal form to conduct the first normalization. During first normalization process, we found the following 2 dependencies need to be handled, which are partial dependencies and transitive dependencies. In partial dependencies, we have 3 tables, which is users table, products table, and user actions table. In users table, username, email, and user created app are depend only on user ID. In product table, product name, description, average rating, product created app depend only on product ID. In the user actions table, action type and user action created app depend on the composite key, which consists of user ID and product ID, ensuring that each combination of user ID and product ID is unique. For transitive dependencies, we have 3 tables, which are review table, categories table, and product categories table. In review table, feedback depends on rating, as different rating may elicit different feedback content. In categories table, category name directly depends on category identifier, with each category name determined by its corresponding identifier. In product categories table, the relationship between products and categories is interdependent through product identifiers and category identifiers to forming their connection. About second normal form, we have 3 tables, and the necessary foreign key are included during the second normalization process. As shown in user action table, we have added user ID and product ID as foreign key. For a third normal form, we have third normalization process. To enforce uniqueness and make queries more clearly, action ID as the primary key is added to the table user actions. The table of transitive dependencies in first normal form, which is reviews table, categories table, and product categories table, will have a change during third normalization process. For reviews table, it is found that there is a possibility where some users may make different rating on the similar products again, so reviews ID as primary key is introduced. Additionally, user ID and product ID are also included as foreign key in the reviews table. This foreign key establishes relationships with the user and products tables. And third tables is categories. As categories name is not suitable to use as the primary key, thus category ID is introduced as the primary key. The last table is product categories table. Since the product ID and category ID is linked to and get from table products and table categories, so they become the foreign key and suitable to become primary key. And this is the data dictionary for the customer feedback system by including 6 tables, which are users table, products table, reviews table, categories table, product categories table, and user actions table. So that's all from me. Now I will pass to Z for demonstration.
While the system worked well, we have found a few areas where we can improve, like adding more user action type and optimizing it for a larger data set. In the future, we plan to enhance user behavior tracking, improve privacy protection, and make the system even faster. Thanks for listening.
Okay, thank you, Jiayun. Hello, my name is Quizy. Our database is a customer feedback and review management system, which aims to collect and manage customer feedback on the product. So I will demonstrate how we use SQL components like DDL, DML, trigger, procedure, and function to make the system work. First, here we use DDL to create a table named user for storing the user information, include name, email, and also user ID, which is the primary key for the user table. The create at column is a timestamp that automatically record the exact date and time when a new record is added to the table. And also we have product, review category, product category, and also user action table here. So for the review table, user ID and product ID are foreign key. User ID connect to the user ID in the user table, and also product ID connect to the product ID in the product table. This makes sure that every review is linked to a valid user and a valid product. Next, for the DML, it's used to add and query a data. We used to insert into like this to insert the data into the user table. Then we can query the data by using select all methods like this. Then here we can see the user table here. So right now, let me to insert all the value that we have to insert. So after I've finished the value that we have to insert, let me explain about the trigger. So for the trigger, we use it to automatically update a product's average rating whenever a new review is added. Now I will show how this is working. First, we can check the current rating first. Like this. Then I will add a new review for the product ID 1. Like this. Here, I'm adding a new review for product ID 1. The rating for this review is 4. When I insert this review, the update average rating trigger will automatically recalculate the average rating for this product. Then we can check it again. So for here, you can see the product ID 1. The average rating has been updated automatically by the trigger. Next is the procedure. The procedure is like a pre-written script that handles multiple steps, and we use it to add, review, and update the product's average rating at the same time. We can use like this. So by using the procedure, we no need to add a review like this. We can simply use the procedure to add a review like this. So again, we can check the average rating. As you can see, the average rating for product ID 2 has been outdated. Last is the function here. This function calculates and returns the average rating for any products. For example, we can use this function. Then this returns the average rating for the products with product ID equal to 1. That's all from me. Thank you.